The largest rocks standing at Stonehenge are called sarsens. Before they were ever stood upright, they were raw, massive boulders scattered across the English countryside, with the heaviest among them weighing up to 40 tons. That is roughly the mass of a fully loaded commercial airplane. The people who decided to move these stones, roughly 4,500 years ago, had almost none of the technology we associate with heavy construction. They possessed no wheeled vehicles capable of bearing that kind of load. They had no draft animals bred for heavy hauling, and no metal tools harder than bronze. A modern steel cable might easily tow a 40-ton weight, but the fibrous, plant-based ropes of the Neolithic era would simply snap under the tension if pulled directly across the ground. Then there are the smaller uprights, known as bluestones. They are lighter, weighing between 2 and 5 tons each, but their origin is far more extreme. Geologists have traced the exact mineral composition of these rocks to a specific set of outcrops in the Preseli Hills of Wales, a rugged landscape located 150 miles away from where the monument stands today. Every discovery at the site points to a reality defined by brute force prehistoric physics and a level of human coordination rarely seen in the ancient world. The builders faced two distinct transport problems. They had to drag the massive 40-ton sarsens roughly 15 miles across the Marlborough Downs, and they had to navigate the 5-ton bluestones across 150 miles of rough terrain, rivers, and coastlines. To move heavy loads overland, they built continuous wooden conveyor systems. Workers lashed the stones to heavy timber sledges and then laid down a track of log rollers ahead of the sledge. As the stone moved forward, the logs left behind were picked up and rushed to the front of the line to keep the path going. This diagram illustrates a specific mechanical refinement they likely used to reduce friction. Instead of relying purely on cylindrical rollers, which easily veer off course, they placed the sledges on a track of horizontal wooden sleepers. By rocking the sledge slightly from side to side and pivoting it forward along these rails, they drastically cut the friction between the wood and the ground. Using this exact technique, experimental archaeologists have proven that the workforce required drops sharply. A highly coordinated hauling team of between 20 and 150 people can maintain a slow, steady pace, even with the heaviest stones. Mastering this specific method of friction reduction turns a seemingly impossible task into a predictable, mechanical process. It was a grueling logistical marathon, requiring enormous quantities of felled timber and perfectly timed labor, but it was physically achievable. Arriving at the site was only the first half of the operation. The builders then had to stand these top-heavy, multi-story rocks completely vertical. Without cranes or hydraulic lifts, a single slip could easily crush a work crew or snap the stone in half. We can see their solution in this cross-section of the foundation. They dug deep holes, but left one side cut at a gentle slope, forming a subterranean ramp. The opposite side of the pit was dug as a sheer vertical drop. As the stone was dragged to the lip of the pit, the pulling teams set up a tall wooden A-frame. By running ropes over the top of this frame and hauling from the far side, they created extreme leverage, shifting the stone's center of gravity until it tipped naturally over the edge. Gravity then pulled the base down the ramp, rotating the stone upward. The sheer face of the pit was lined with thick timber posts to absorb the impact and guide the rock into a vertical position. Once upright, workers permanently locked the base into place by tightly ramming crushed chalk rubble into the remaining void. The builders succeeded because they did not try to fight the crushing mass of the stones. They engineered a system of levers and ramps that let gravity do the heaviest lifting for them. The most dangerous engineering hurdle came last. The builders had to hoist massive horizontal lintel stones, weighing several tons each, roughly 24 feet into the air to cap the uprights. Physical evidence suggests they used a method called timber cribbing. They built a wooden tower entirely around the standing stones, adding layers of interlocking logs one course at a time. The lintel would be levered up onto a new layer, the logs would be stacked higher underneath it, and the process would repeat until the stone sat flush with the top of the uprights. Once positioned, the lintels were locked into place. This 3D model highlights hidden woodworking joints carved directly into the hard sandstone. You can see protruding knobs on the tops of the uprights, designed to slide perfectly into matching hollows carved into the underside of the lintels, mortise-and-tenon joints executed in solid rock. Horizontally, they carved tongue and groove joints into the ends of each lintel, so they interlocked into a continuous ring. Even more demanding, every single lintel stone was individually carved with a subtle inner and outer curve to match its exact radial position. This bespoke joinery integrates the stones into a unified structural system, where every block is shaped to fit a single calculated plan. Decades of continuous labor, more than 30 million work hours invested in extracting, hauling, raising, and carving these specific materials. Why commit an entire agricultural society to a project with no practical utility? The answer is written into the layout of the stones themselves. The entire monument is built along a deliberate geometric axis that perfectly frames the exact point on the horizon where the sun rises on the summer solstice and where it sets on the winter solstice. For an agricultural society dependent on seasonal cycles, this alignment provided a permanent physical calendar marking the turning points of the year. Beyond timekeeping, excavations reveal the site also served as one of the largest cremation cemeteries of its era, marking it as a sacred domain honoring their dead. This data visualization tracks ancient DNA extracted from Neolithic burials across Britain. It reveals that right in the middle of this 1,500-year construction project, a massive migration of new people arrived from the continent. Within a few centuries, this incoming population